Good morning, good afternoon, and good evening, everyone. Thanks for coming back with us for a very exciting panel of lightning talks, which are going to feature our colleagues from institutions both in the United Kingdom and in North America, talking about some of the collections that they work with on a daily basis and how they approach some of the challenges that we've been talking about over the last couple of days. Again, my name is Jim Ambuski. I am from the Center for Digital History at the Washington Library at Mount Vernon here in Virginia, and I'm delighted to be with you here today to moderate this panel. Just a little bit of housekeeping. I'll introduce each presentation in turn over the course of the next hour, and after that hour is complete, after everyone has gone and done their bit, we'll take a 10-minute break and come back for questions and answers after that. So over the course of these presentations, please do pop your questions into the Zoom chat. I'll be looking at those and preparing to moderate a Q&A session when we come back for the break. With that out of the way, let's get rolling. And with no further ado, I'm very delighted to welcome my colleague Fergus Smith, who is the proprietor of Old Scottish, a history firm there in Edinburgh. And he's going to be talking to us about a probabilistic numerical approach to record linking. Fergus, the floor is yours. I think you're muted.
Yeah, inevitably what I just said was I'm just checking sound. Right, I'm going to try and share my screen. Right, there we are. Okay, before I start, I should point out that this presentation is very much about a work in progress. It's based on a project I've been developing in the background to support other data projects we've been working on. It's very far from a finished product or even a fully functional beta test, so please forgive me for the inevitable roughness around the edges of this paper. That and the terrible slideshow. Graphic design is not one of my strengths. Oh. Historical record sets come in many different flavors. In this paper, I'll primarily be considering records that involve named individuals. Some record sets will ordinarily only ever have one record for each named individual. Civil registers of births and deaths, for example, because people were generally only born once and die once. Other record sets may have multiple entries for some individuals, court records, for instance, or hospital registers. By record linking, I mean the process of determining that two records relate to the same individual. This can be done both within a single record set and between different record sets. Record linking produces numerous benefits for the historical researcher. It enables individual timelines to be developed, allowing researchers to elucidate stories from raw data. Think of tracing the successive court appearances of a career criminal, or the ongoing treatment of a patient admitted to hospital on multiple occasions. Linking across record sets allows a bigger picture to emerge. If we think of a record set as broken down into individually potentially identifying fields, so name, occupation, location, date, relationships to others, and so on, we can see how record linking can be done. The process involves comparing pertinent fields from two individual records and determining, on the basis of their similarity or otherwise, whether the two records relate to the same individual. As an aside, I'm talking here about structured record sets that can be analysed into multiple fields. Imagine they could be constructed by filling out a form. Many record sets are not inherently structured in this way. However, the process of cataloguing produces metadata relating to individual items, records, and people, and these metadata records can in turn be used as a proxy for our purposes. For small record sets, it's fairly simple to link records together. The same applies when trying to link small subsets to selections of records within very large record sets. This is, after all, what millions of amateur genealogists, to give but one example, do on a daily basis, searching in some cases extremely large record sets for items that match the specific criteria of the individual being sought. However, when it comes to linking all the records in a record set to each other, or to records in another record set, problems quickly mount. The number of comparisons required increases exponentially. If we want to compare each of the X records in a data set to all the other records in that data set, the number of comparisons is, for the technically minded, X squared plus X over 2. So to compare 10 records with each other requires 55 comparisons. If we have 100 records, we need 5,050 comparisons. the number of comparisons increases rapidly. So if we want to link non-trivial record sets together, we need some form of shortcut. One possible approach would be a fully automated matching algorithm. This involves comparing two records across all the pertinent fields, and where all the fields match, we could conclude that the records relate to the same individual. This has the benefit of simplicity in terms of both conception and implementation, but it is, I would argue, fatally flawed. To borrow terms from diagnostics that we have sadly become familiar in the current pandemic, there are two pertinent measures: specificity and sensitivity. Fully automated perfect matching will often reduce the specificity rate. In other words, it will have a relatively high false negative rate, failing to identify a significant proportion of true matches, for instance, because a person's surname is spelled differently in two different record sets. On the other hand, perfect matching tends to perform better in terms of sensitivity, meaning that a high proportion of the records it identifies as matching are in fact true positives. However, successful sensitivity can significantly depend on the nature of the records being matched. One record set we looked at, admission registers for patients in Scottish mental asylums, included a sequential admission number that theoretically uniquely identified each patient. However, it would be dangerous to assume that this is therefore a foolproof method for record linking. In the case of the asylum registers, a non-trivial proportion of the records recorded the admission numbers incorrectly, which would result in false matches. None of this, however, can be taken out as outright rejection of automated matching. It can work, and in some situations, it can work very well. Another test we carried out involved transcribing the civil registers of births, marriages, and deaths for a single parish, Kinclaven in Perthshire, from 1855, when civil registration was introduced in Scotland, to 1960, when Kinclaven ceased to be a separate registration district. Such registers are the bread and butter of family historians, providing the skeleton for family trees. Our test involved attempting to automatically link these records to reconstitute the population of Kinclaven, building what might be termed a family forest of many individual family trees. These registers are highly structured records, and methodologies for manually linking them are well established. The record set comprised 1,102 births, 247 marriages, 805 deaths. A couple of points about these records. For one thing, they're open record sets. While it's reasonable to assume that they're comprehensive in that they cover all the vital events that occurred within Kinclaven Parish, any given birth may or may not have a corresponding marriage record or a corresponding death record. An individual may not have got married or may have left the district. While a birth will match with at most one death record, and vice versa, birth and death records may match with multiple marriages. Manually matching these records, potentially involving well over 1 million comparisons, while theoretically possible, would be very time-consuming. An automated perfect match algorithm was applied to these records. This produced multi-generation pedigrees, with the longest covering 6 generations. Because of the highly specific and structured nature of the underlying records and the constraint of applying perfect matches, the problem of false positives did not arise. However, the problem of false negatives was a different matter. A significant number of records that were certainly linked were not connected using the perfect match algorithm. There were several reasons for this: inconsistent spelling, alternative terminologies, clerical errors, and incomplete information. These are issues that anyone researching in historical records will be familiar with. So are there ways to get around this? To an extent, yes, but we should tread carefully when doing so. One approach is to parse the data fields before attempting to match them. There are several ways of doing this. One option is purely algorithmic. There are a number of algorithms used to encode surnames, most famously SoundX and its variants. The idea around them is to attempt to get round the problem of spelling variants by using an algorithm to encode names that are variants of each other. Most of these algorithms are potentially useful, but are highly problematic when it comes to fully automated record matching because of the strong potential for false positives. Another useful tool is the idea of an authority table. This involves building up a metadata set of possible values for semantic entities, occupations, forenames, surnames, place names, and grouping them into standard versions or categories. As anyone familiar with historical records will know, standardized spellings are a relatively recent phenomenon. My own surname, Smith, the most common surname in Scotland, has 4 relatively common spelling variants in the historical record, and a number of other less common ones. Other names have many more variants, and, despite the persistent myth to the contrary, until very recently the Scottish Mick and Mac patronymic prefixes were used entirely interchangeably by clerks, sometimes even within the same sentence. Authority tables can be a powerful tool, but they have several drawbacks. They require a corpus of entities to be developed before they can be useful. In our work, we've indexed or extracted something in the order of 1 million records of named individuals. This has resulted in somewhere where over 22,000 surname variants and around 40,000 forename variants. The process of creating standardized versions of these is very time-consuming, but on the plus side, it's a one-off cost in terms of time. Our approach was to use algorithms, one flavor of Soundex for the most part, to categorize the entities into possible groups and then manually mark them up. Although this took a lot of time and was frankly tedious, it's been a worthwhile investment, as it significantly reduces the computational complexity of subsequent record linking exercises and is potentially much more accurate than purely algorithmic standardization approaches. Forenames have additional challenges compared to surnames. As middle names became more widespread, in Scotland at least this happened in the late 19th century, the opportunities for variations to refer to the same person also increased. This is part of the reason why our data set of forenames is substantially larger than our surname set. However, Scots were notoriously conservative in their choice of forenames, so they tended to choose from a fairly small pool of names. Across our data sets, more than a third of all males were called John or James, and the 10 most common forenames accounted for more than 80% of all men. For women, the pattern was similar. Over 30% of women were named Jane or Mary, and the top 10 accounted for 82% of all women. By contrast, standardized surnames were much more diverse. The 10 most common surnames accounted for less than 12% of all records. In addition to enabling what is sometimes called fuzzy matching, building up authority tables to include record counts has an additional advantage that can be exploited using frequency analysis. To illustrate what I mean by that, let's look at two names we've encountered in our records, John Robertson and Mungo Thorburn. John is the most common standardized forename in our records, while Mungo ranks 113th, accounting for just 0.06% of all individuals. Names more common than Mungo accounted for more than 97% of all individuals in our corpus. Likewise, Robertson is the most common surname in our corpus, while Thorburn ranks 410th, accounting for just 0.05% of all individuals. It stands to reason, therefore, that all other things being equal, two records referring to someone called Mungo Thorburn are significantly more likely to refer to the same person than two records named John Robertson. By way of illustration, there are 2,670 references to a John Robertson in the National Records of Scotland archive catalogue, but only 3 to a Mungo Thorburn. And as it happens, all 3 of those Mungo Thorburn records relate to the same individual. The same rationale applies to other field categories, such as locations and occupations. At any given time in a particular territory, some jobs will be more common than others, and some locations will be more populous than others. Quantifying the frequency of occupations is more challenging than names for a variety of reasons. People's occupations change over time, and the descriptors used are often far less consistent than even the most widely misspelled names. That said, for some occupational categories, there may be opportunities to use authority tables to classify occupational descriptors into broad categories, such as law, agriculture, mining, combined with perhaps census reports on occupational status to offer at least some indication of frequency at a given point in time. Locations have a different complication, repetition. There are no less than 101 places called Burnside in Scotland, 32 of them in Aberdeenshire alone. There are also 85 Newtons, and over 1,000 toponyms refer to at least 5 different places. Sometimes context will identify the specific place, but not always. Even so, a gazetteer linked to historical demographic statistics may help. Bringing all of these together into an algorithm is non-trivial, but certainly tractable. As I mentioned earlier, this is still very much a work in progress, but we have begun experimenting with weighting of different factors. Our initial approach is to weight personal names heavily, as these tend to be consistent over time, with the obvious exception of women who marry and take on their husband's surnames. Here, the Scottish approach of women retaining their maiden surname is helpful for identification purposes, but is not foolproof. Occupations were, of course, far from immutable. People did change jobs in the past, although some types of occupation were steadier than others, the church and the law being two clear examples in Scotland, and skilled trades are another instance. So occupational weighting could entail a combination of broad categorization and the value for occupational stability. Once again, this could potentially be tweaked to take account of specifics of time, place, and record collection. Ultimately, our objective is to produce a numerical score based on a combination of values for each field. These values would be derived from field-specific weights, a frequency measure, and potentially a closeness of match value. Our next planned step, which is currently in production, is to produce a prototype based around the conclaven family forest data described earlier. We would use a manually generated family forest for comparison to test various permutations of the weighting values and possible threshold values for full automation. After that, we would then aim to build a system to allow us to test this approach on a new record set or sets with ultimately parameterizable values for weighting. Anyway, that's me. I hope that was all right.
Fergus, that was terrific. Thanks very much. I think you've given us a lot to think about, and especially as they're thinking about our own work with the session papers, a lot to panic about. So, so we look forward to talking with you more, and a reminder to the folks too to pump your questions in the chat, and we'll have an opportunity to ask Fergus some questions here at the top of the hour. All righty. It is now my pleasure to welcome two colleagues from the Folger Shakespeare Library in Washington, D.C. Heather Wolf is the curator of manuscripts at the Folger, and Emily Wall is the metadata librarian. And they'll be speaking about transcription as description, searching manuscripts in the Folger's digital image database using full text search.
Thank you very much, Jim. And I just want to make sure I see Emily. Okay. Thanks so much for allowing us to share our transcription project at the Folger with you. We are excited by the possibility of including editor and transcribists into our workflows and have learned so much from the presenters these past 3 days. I'll present first, giving a bit of background on transcription and crowdsourcing practices at the Folger. And then Emily will talk about one of the ways that we are making our transcriptions available online. And then we'll wrap up with some ideas about how we might want to move forward in the coming years. So first, stay on this slide, Emily. Lessons learned. From 2014 to 2018, the Folger had a grant from IMLS to develop something we called EMO, Early Modern Manuscripts Online. This grant allowed us to further develop our existing transcription platform, Dromio, which was created by Folger data architect Mike Poston. And it also allowed us to develop a prototype EMO website created by Mike Poston and Rebecca Niles that contained beautiful TEI-based transcriptions of a select number of letters in our collections. And we can drop these websites into the chat. During this period of the grant, we also held virtual and in-person transcribathons in the US, Canada, and the UK, and partnered with Zooniverse, and specifically Victoria Van Heining at the Zooniverse and the Oxford English Dictionary to create a crowdsourcing site called Shakespeare's World. We also taught hundreds of people to read secretary hand through formal instruction, a series of ongoing sessions we call practical paleography, and the development of various teaching aids, which we shared widely online. We hoped that the addition of millions of newly discoverable handwritten words that record the experiences and voices of women and non-canonical, non-elite, and marginalized people would contribute to a reassessment of long-held assumptions about literacy, domestic arrangements, social networks, and self-determination in early modern Europe. This was all wonderful and amazing, but the process of getting high quality transcriptions out of Dromio and into our EMO platform required a lot of steps. If we later found an error that we wanted to correct, which we often did because paleography is an art, not a science, it was not easy to make the change, and we couldn't make it ourselves as paleographers. We ended up having thousands of transcriptions that didn't make it onto the MO website by the end of the grant because of all the work that needed to happen after each document had already been fully transcribed and vetted. For a mass transcription project, we were spending too much time worrying about brevigraph type or deciding on ambiguous words that really were just totally ambiguous. This was not scalable. We needed to readjust our paleographical and archival hats and really just focus on access. So when the grant ended in 2018, we had hundreds of transcribers who wanted to keep transcribing. I didn't want to stop them. And in fact, I couldn't stop them. They kept coming to Dromio and transcribing. After all, we were a community, and the work they were doing was so valuable that even if we didn't yet have funding or a strategy for getting the transcriptions out of our interface in a simple way, we wanted to keep going. Shakespeare's World, the Zooniverse project, attracted almost 4,000 registered volunteers and an unknown number of anonymous participants who just didn't sign in when they made transcriptions. They transcribed over 11,000 digital images in 4 years. Roughly 19,000 additional transcriptions of digital images have been produced in Dromio between 2014, which was the beginning of the grant, and 2021, by hundreds of Folger docents, Folger staff, paleography students, pedagogical partners, Transcribathon participants, and volunteers. And several, I would say maybe about 10 volunteers from Shakespeare's World, once we sunsetted that, migrated over to Dromio with us. And then thousands of additional images have been transcribed as part of our pandemic paleography efforts. So Emily, go to the next slide. I'm just going to quickly show you what our Dromio transcription interface looks like. You can see we have shortcut buttons, which translate into XML tags. And then we also have subject buttons for names and places and amounts. But we were trying to minimize the number of tags that we used in creating these transcriptions. Next, Emily. Dromio also has a collation interface. So when we have people transcribe, we have right now people making 3 blind transcriptions at least, and then we run an algorithm to put them on top of each other so that the differences show up in red. And this is really useful for teaching purposes. Next. And then we also have a vetting interface, and this is what collates the words as well as the tags, and it chooses the sort of majority rules tag and transcription of however many transcriptions were made of that document, and it produces a pretty high quality transcription that just needs a little bit of massaging at the end. We knew in this next unfunded phase of MO, and this is the MO platform where you can view the results from Dromio in diplomatic, semi-diplomatic, and regularized transcriptions, and you can download the XML. So this was the grant funded version, and we are now post-grant. So we knew in this next unfunded version phase of MO that we needed to switch strategies. We needed to find a way to make our tens of thousands of very good transcriptions available as quickly as we could and make them easily correctable if people noticed errors. If they weren't shared as perfect TEI P5 encoded transcriptions, that was okay. If they weren't searchable via normalized spellings, that was okay. As has been said many times over the past 2 days, if we waited until they were perfect, no one would ever see them. We knew that even a not so great transcription would lead many users to our manuscripts who never would have found them otherwise. We knew that our manuscripts were not just for trained historians, but that our metadata sometimes acted like they were. We also knew that the first point of entry for research, no matter what your training, is usually an internet keyword search, and that most people assume that if something isn't online, it doesn't exist and isn't worth the effort of tracking down. We also knew that even the richest description of a manuscript can't capture everything. And by highlighting what we thought was important, and this came up in the discussion this morning, we might obscure what someone else might find important. We needed full text search. So Emily will describe the strategy we created, which we are able to execute within a day of the idea being hatched, utilizing our current digital image database, Luna. In my remaining minutes, I'll just wax lyrical about the benefits of crowdsourcing, because we haven't really fully grappled with that yet in this workshop. So similar to the participatory archives movement, crowdsourcing represents a potentially transformative shift in how access to collection material is created and who creates it. We can upend the power structure of the archivist cataloger disseminating partial information to others through privileged access to collection material, and work together to create an open and transparent framework for accessing material at all stages. Through transcription and HTR correction opportunities, archivists and volunteers become partners in a collaborative effort to unlock the text of digitized manuscripts and make it freely discoverable to anyone with an internet connection. Learning and discovery flow in multiple directions. And I just have to say, we have made hundreds of tweaks to our finding aid descriptions because our transcribers, as they're transcribing, check our finding aid and notice errors that make sense how they were made when the people, the archivists describing them, didn't have access to a full transcription. Individuals who may never have previously engaged in a cultural institution's programming or visited it in person now become co-creators of content, and they help our institution reach even more people like them. User engagement is that much greater when a person is invested in making knowledge rather than just reading a transcription. We've learned that creating better access is about inviting others into the process of content creation, opening up our reading rooms virtually, and inviting volunteers to connect with archivists, librarians, catalogers, researchers, and other collaborators all over the world. It takes time, but in many ways, it is similar to traditional reference work. We're just turning our reading room inside out, basically. So now I'll turn it over to Emily, and then we'll come back with some final thoughts. Over to you, Emily.
One moment. So as Heather mentioned, Emma was a really fabulous platform, but even after transcriptions were made 3 times in Dromio and then collated and embedded, it still took quite a bit of hands-on work and expertise to prepare them for MO. So she approached me about 2 years ago about sharing transcriptions on Luna as a less ideal but much more immediate way of providing access to these transcriptions, with the philosophy something is better than nothing, and we'd rather share a less ideal version than leave these just lingering on a network drive where no one can see them. So this is a quick snapshot of what the process looks like. So all of these images already live in our Luna platform, and they all have metadata already associated with them from the catalog or finding aid. So title, creator, date, page number, that sort of thing. So I'm able to just copy all the images over from their existing collection and grab all the existing metadata. In Dromio, because Luna hosts the images from Dromio, you can see up top on the right here, the transcriptions are already broken up by page image and includes the same file name that we use in Luna. So I have something to match on really easily. I just bring everything into Python. I grab just the vetted transcription from each page image, turn it into plain text, pop it back in the CSV, and upload it to Luna again. And the whole process from start to finish doesn't take more than a few minutes. So the result of that is that all of these transcriptions live in their own collection on Luna, And the transcription is just another field in the metadata record. On the left here, you can see an example of what a transcription looks like in Dromio and what that same snippet of the same transcription looks like in Luna. And just at a quick glance, you can see that a lot of information has been lost because we are just limited by what we can display in Luna. Luna does support Unicode, so we can include things like alchemical symbols. But we can't use superscripts, text, italic text, strike-throughs, different colors. So we lose a lot of the ways that we normally represent things like superscript text that was silently lowered or abbreviations that were expanded. Still, it's been hugely beneficial for us because even in the simplified form, it enables full text search. So as a quick example, earlier this week, I actually needed to find a number of potato pie recipes in our collection. And in the past, I might have just had to hope that those specific recipes were mentioned in the recipe book's catalog record, or that maybe a reference librarian would remember seeing one. But because we had all these recipe books in our transcription collection, I was able to just perform a quick search and find a number of options. For more advanced researchers, we've also enabled backend access to Luna. They can't edit the records, but they can search and browse just as they would on the front end. And then crucially, they're able to export the results as a CSV and do more in-depth analysis outside of Luna. So we've had this for just over 2 years now. We're up to just over 11,000 transcribed page images in the collection. And we have averaged about 2,500 views per month, but that number keeps going up, and especially over the past year. And we had, reports from users too, that they've really relied on the collection for articles they've written or projects they've done. So I will turn things back over to Heather.
Okay, great. Thanks, Emily. So this Luna solution is really a stopgap measure that has taken on a life of its own. And in many ways, it's only a baby step in the Folger's commitment to radical access to our collection. We're closed for renovation right now, so we have a little bit of time to think about it and get ready for reopening. But we hope to start a citizen scanning and metadata project. We're inspired by the National Archives in Washington, DC, and a successful scanning project that they have with volunteers coming in and either supplying or connecting, attaching metadata to the images that they're scanning. And we hope to start a workflow with new acquisitions that has them getting digitized and transcribed as part of the cataloging process. We want transcription to be a key component of the descriptive metadata process. And we think we can do this if we continue to engage with and expand upon our many newfound audiences and knowledge co-creators. You'll see, I'll end with this set of slides, starting with this one. And the little paragraph on the bottom that describes the source of the transcriptions made by Shakespeare's World volunteers, participants in MROC classes and transcribathons. MROC is the Early Modern Recipes Online Collective, and they've been instrumental in helping us transcribe all of our early modern English recipe books in manuscript. And then participants in Folger paleography classes and transcribathons, and Folger docents who have turned out to be an incredible group of people who are so interested in transcribing and making these texts available. And I'll also add to that, during the pandemic, Folger staff, we've managed to teach almost the entire collections group, so perhaps 20 out of the 29 of us in collections, how to read English secretary hand, because it's something that everyone can do from home. Can you go to the next slide? We've also tried to recognize all of this labor, which sometimes gets hidden when people just see the transcriptions, through blog posts where we name people by name and just talk about the community that is created through this knowledge co-creation process. And then next. we've also, since there isn't, since the XML isn't easily accessible at this point, it's available upon request, we have all of the usernames of our contributors embedded in the XML. And here we've pulled it out, and you can click on the content or scroll down on this page, and you can see all the usernames who contributed a transcription that was then published. And we hope that this encourages people to continue participating, because, you know, for students and academics, it can be a line on your CV, I think. And next. We've also tried to credit them in places, other places like Folgerpedia, where we have all of our recipe books grouped together and links to transcriptions of them. And here, you know, we're starting to think about not just the labor of the transcribers, but our digital imaging team, the docents, the people who are doing the vetting, which is painstaking work, and that has ended up being Folger staff and some volunteers that we've met along the way. And then the work of Emily and Mike Poston and Elisa Tersini, who have all, I mean, it's just the amount of collaboration to get these things online is astounding, as all of you know, and as you've demonstrated during the past 3 days. So how do we embed this data of all of these contributors, all of these helping hands into the transcriptions themselves? And I hope we can discuss that in the questions. Thank you very much.
All right, thank you very much, Heather and Emily. That was terrific and very thought-provoking, and great to see such active citizen engagement in those projects. It's really fascinating to learn about. Let's keep going along now, and I'm delighted to introduce Wasim Farouk, who we just learned in the green room before we came out, was just recently promoted to reference and instructional librarian at the Aga Khan Library there in London. So congratulations, Wasim, and he'll be speaking to us about unveiling hidden collections, the case of the Bengali titles. The floor is yours.
Thank you. I'll just share the screen. So is that visible? Okay. Hello there. So I hope you can see my slides.
Yeah, you're good.
That looks great.
You can see my camera. Okay, so thank you very much, everybody, thank you very much for the opportunity to present my project, and thank you all for being present here. I am Wasim Farouk, and recently been appointed as a reference and instructional librarian, and have been working at the Aga Khan University since 2005. Previously, I've worked at the British Library as an Arabic cataloger from 2002 to 2005. Okay, so I'll just give you a bit of a background. Our library is an amalgamation of two libraries. The first one was established in 1977 at the Institute for Ismaili Studies in London, and the second one, the Institute of Ismaili Studies, and the second one was the Aga Khan University's Institute for the Study of Muslim Civilizations, which was established in London in 2002. So in 2009, both the institutes co-located on Euston Road. So both institutes came into one building. So the library was a shared library from then on. And from then on, the merging process began until 2014, when the library staff was merged under one head librarian. So since 2014, the library was just called generically the IIS-ISMC Joint Library. But from the Aga Khan Library, the name was and the building was inaugurated in 2018 when we moved to a new purpose-built building behind King's Cross Station. The building itself is called the Aga Khan Center. Within the Aga Khan Center, there's the Aga Khan Library and also the two institutes. So the backlog. So at the ISMC, the Institute for the Study of Muslim Civilizations, the ambition was to collect works on Muslims from around the world, whilst being mindful of the collections that already existed at the British Library and the School of Oriental and African Studies in London. So at the time, we hired a Bangladeshi PhD student to help us with the purchasing of the Bengali books in 2007. However, we soon faced issues since we had a policy of ensuring that all non-Latin scripts records should include the original script of the book. We struggled to find a script that was workable back then. So a script that could be used in our library management system and that could be indexed correctly and that would display correctly on the OPAC and would be searchable by our users. So according to our Bengali scholar then and the library management system vendor at the time, this was not possible. Over time, we had no one else to work on the books as it was quite a challenge to find a cataloger, and also with the moves that we did and the mergers, the Bengali collection became our backlog. So there were about 300 titles that were purchased back in 2007. So, however, as Unicode has now developed quite well and OCR capabilities have improved, and also HCR capabilities, as we have witnessed in the past few days, we have now realized that we can scan the title page and title page verso and then copy paste the script in order to catalog the Bengali books. And this is after almost 13 years. So recently, I have been working with cataloging the Bengali books in the Bengali script, despite having little knowledge of the language and barely just learned the script. We are still in the testing phase. So we are still in the testing phase, but confident that we can upload the data and make titles visible and discoverable by users. So this is how we worked. In this sort of here, I will be referring to WorldCat and OCLC a lot. As we used WorldCat and OCLC, we do use them for our cataloging, and we contribute to OCLC and also use them for copy cataloging. Since some books some of the Bengali books have ISBN numbers, we did obviously retrieve some results in the past, but also the issue was that I mean, the older Bengali books that did not have ISBN numbers, and even if they had ISBN numbers and we could receive the records, we would ideally like them to also have the Bengali script included within the records. So this is so our procedure was thus that we took an image of the title page and title page verso by using a mobile phone or either scanning it on scanners. Saved the image as a JPEG and then uploaded the image to a Google Drive. Once in Google Drive, you can view the image there, preview it, but also you can open. So you can open the image with Google Docs. So rather than opening the image as an image, if you use Google Docs to open that image, the magic happens. The text is automatically transcribed. And we have our transcription here. So on the left, you can see the image of the title page that was scanned. On the right, in clear Bengali script, is the transcription from the scanned image. And I've also included the transliteration here, which was, I used Google Translate to, obviously Google Translate helped in terms of to understand what the word means, and also helped with the transliteration as well. So once I had the transliteration, that also helped me to find the book, was an alternative way of finding the material on WorldCat as well. So obviously if the book didn't have an ISBN, and sometimes even though the book had an ISBN, the titles weren't in WorldCat. So then I used the, using the Bengali script to search in WorldCat is very difficult to retrieve results because most of the records, older records especially, do not have the Bengali script included. So I used the transliteration, which was done by Google Translate. Although the library standard is to use the Library of Congress romanization tables, but this transliteration provided by Google was not very far off and did bring up a lot of hits. So, and the accuracy of the Bengali script was very good. I mean, I learned enough Bengali to be able to distinguish letters, so I could compare the scanned image of the title page and the transcription, and I could see if identify if there was any issues. Okay, however, okay, so I'll just highlight some of the issues. Maybe. Okay, so some of the issues that I've been able to identify, and also I have had some help from colleagues at the British Library, although they themselves do not use the Bengali script within the records. I did ask for some assistance in a few months ago for them to compare the Bengali script with the transliteration and to see if it was correct. And they pointed out as well that the raw letter is not in the script. Is not the Bengali raw R letter, but it's the Assamese. So you can see in the image in the middle, the Assamese R is displayed, Ra is displayed rather than the Bengali one. But that wasn't an issue. That was something. The word was correct. So even though if it was in Assamese, if you searched this word in WorldCat, it would retrieve all the results. So it would retrieve the results with the Bengali raw character, R character, and also the results with the Assamese R character. So it didn't really pose much of a problem. And also this same word, if you were to put this word into Microsoft Word or Outlook, it would show correctly as the Bengali R should be, but when it just depends on the application. And also another issue was of the vowel markers. Some of the vowel markers were not in the correct place. So rather than the usual place for the vowel marker is either underneath the letter or before the letter, sometimes the vowel marker was after the letter. So in this image at the bottom, Rajaniti, and the vowel marker is at the end, and the correct version is just written above that. And so despite these issues, I mean, obviously it was more of an issue of display. So when I was working inside OCLC, so in the top image here is the connection client. It was showing correctly. I've encircled in red. On the left-hand side is the word dharma, written correctly as it would in the Bengali script. And on the bottom image on the left-hand side encircled is the word dharma again. But here the Assamese letter was visible. And also the same issue with the vowel marker was correct in the OCLC client, and in the WorldCat it was showing slightly misplaced. But despite that, but this was which I uploaded in August 2020, and I didn't have a look at it after that. But I will get back to that. And also there were some issues with the numbers as well. So sometimes the number 6 was showing as the 7, or sometimes number 7 was showing as number 8 as well. And in here, I'll show, this is where I used Google Translate to obviously translate the image as well, the text, the Bengali text. So as you can see in the circle one, the top one is Bengali, and in the middle is the transliterated version. The transliterated version 700073 is correct, but at the bottom is the translation. So in the translation, it's showing the wrong number. So the first character is 8 rather than 7. So I'm not sure, but anyway, these are things to look out for, and one can correct these as well. But nevertheless, despite these issues, I ran a search with the same title again in WorldCat just last night, and lo and behold, the word the dharma is showing correctly, and also the vowel marker is in the correct place as well. So something has happened in WorldCat, or something's been happening in the background in the past 6 months, and it seems to have improved the display here. Okay, I've probably gone off script. Okay, so again, I'm just trying to emphasize the word dharma and vowel marker. And so despite all the issues, even though it was not showing correctly in WorldCat back then, and it's showing correctly now, but regardless of that, even back then, I tested it in our library management system, and the image here is from our discovery catalog, and in our discovery catalog, it was showing correctly. And also in our OPAC, it was also showing correctly. So it's something that may be an issue of the displays might be slightly incorrect in some applications, but mostly it seems to be self-corrected somehow. Okay, so finally, despite these small issues, one needs to be careful whilst deleting blank spaces as well. So in OCLC client, I had issues. If you're not careful, if you see too much white space and you delete to try to make the word closer to the comma or the full stop, you may incidentally delete the last character of the Bengali script as well. So I think one needs to be wary of that. The process was a little time consuming. It can be time consuming, but cataloging can be time consuming as well. Sometimes a book can take an hour to catalog or longer. It depends on the complexity of the book in hand, and sometimes it's very quickly. So the average was about 1 book per hour, and sometimes I could do 2 books per hour using this method. So despite the display challenges in different applications, we hope that this can be resolved in future updates, just as we have witnessed. Yes, that's the end of my presentation. Thank you very much.
Well, thank you, Wasim. That was terrific. Very informative, really fascinating collection you're working with there, and your approaches to it are really quite interesting. We're getting a lot of questions about it, and from the other panelists in general. So looking forward to talking more with you about that here in just a few minutes. To conclude this particular panel, I'm now pleased to welcome some colleagues from the University College London, Andrew Watson, who is the head of retrospective cataloging, and Vanessa Friedman, who is the subject liaison librarian for Hebrew and Jewish studies. They'll be talking to us about transcription enhancement of digitized multilingual pamphlet collection. And the floor is yours. Thank you very much.
Thank you very much. So I'll just share my screen. Beginning. There we are. So I hope everyone can see the slides. Yes, thank you, Jim. Yes, as Jim just said, I'm Andrew Watson, Head of Retrospective Cataloguing at UCL, and I'm joined by my colleague Vanessa, who is the Subject Liaison Librarian for Hebrew and Jewish Studies. And just to say, I'm one of the few who are not working at home. I'm in our library store in Essex, and so we're on an industrial estate. There could be lorries rumbling past or trucks now and again, so so I hope you just ignore them, block them out if you hear a rumbling going past. But we're going to be speaking about transcription enhancement of a digitized multilingual pamphlet collection. The transcription enhancement took place in a multi-phased project entitled Uncovering UCL's Jewish Pamphlet Collections. And the project set out to catalogue, conserve and digitize several collections of Jewish pamphlets held by UCL Special Collections. The phases were not all planned at the outset. Instead, they developed organically one from another. And so one consequence of this was that there were unforeseen changes in staffing, which meant not all the staff had the relevant experience at the appropriate times. So for example, I ended up being the project manager for all 3 phases, but I'd had very little experience of digitization projects before, and none whatsoever of transcription enhancement. So for me, it was a very sort of steep learning curve. And the table shows a summary of the activities that took place in all of the 3 phases. So we set out to catalogue and conserve the pamphlets. But by phase 2, the focus shifted to digitization, and then this led to the transcription element in phase 3.
The Jewish pamphlet collections cover a wide range of subjects throughout the field of Jewish studies. Andrew, can you mute? I think I'm getting some kind of feedback. So the Jewish pamphlets collections cover a wide range of subjects throughout the field of Jewish studies, particularly, oh, lost the PowerPoint.
Oh, have we?
It's still up, we can see it.
Yeah, it's just not on slideshow.
Yes, I can't mute, I'm sorry.
Oh, don't worry. Right, I'll start that again. The Jewish pamphlet collections cover a wide range of subjects throughout the field of Jewish studies, particularly Anglo-Jewish history, Zionism, and liturgy. Pamphlets date from 1601 to the present, and they're in English, Hebrew, and a variety of other languages, including French, German, and Yiddish. Many of the pamphlets include more than one language, so the example on the slide is in Hebrew and English. The purpose of the digitization part of the project was to enable online access to important texts which were not widely available or which could not be consulted because of poor condition. As we only had funds to digitize a portion of the collection, we used the following criteria for selection: significance, based on date and subject matter; fragility, using the results of the conservation survey that was carried out in phase 1; rarity, and whether the pamphlet was already available digitally. We established these by checking COPAC, now Library Hub Discover. The images were then uploaded as PDFs to UCL Digital Collections, which uses the digital platform, with contextualizing information and metadata.
When the images were uploaded, OCR was applied in order to make the text searchable. However, this original OCR attempt was not retrievable for Hebrew or Gothic script, and as a significant amount of the material was in Hebrew, this was a major concern. So we consulted with the National Library of Israel, who advised us to adopt Abby Fine Reader software to correct the transcriptions, as this included Hebrew as one of the inbit language options. We already held a license for this software, so we chose to follow their advice. I think it's worth noting here that we used version 11 in this project. More recent versions are now available, which I believe resolve some of the issues that we encountered. But our reason for sticking with version 11 was that we'd already done a lot of the preparatory work in this version. And I should also say that the project started in 2014 and went on for 5 years. So the preparatory work was done earlier than some of the transcriptions were corrected. So our initial methodology was based on a transcription enhancement pilot we set up in phase 2. The JPEG files were used to create multi-page PDFs, and these were pre-processed in Abby Fine Reader. So the language, color, and page orientation was set, and text boxes were redrawn for text in columns and tables. Bleed through from the other side of the page could also be corrected. So let's just try and find the pointer. I'm not quite sure I can. Never mind. I'll just use an arrow for now. So the illustration shows the presentation of Abby Fine Reader. So on the left here, we have the thumbnail images of each page of the PDF. And the left-hand page shows the PDF with the text boxes drawn around the text. And below you can see an enlargement of the text. And the right-hand page shows the transcription with possible errors highlighted in blue by the software. And then the editing of the transcription takes place within this pane. One thing we soon discovered was that not all errors were picked up. This meant that transcribers had to check the whole text line by line in order to make corrections as required. And in addition, the software occasionally introduced inaccuracies, for example, replacing spaces with extraneous characters. Vanessa, I think you're muted.
Honestly, I don't know how many times I've done that. After correcting the transcriptions in Abbey, we did some trial searches of the PDFs and were disappointed to find that we weren't always retrieving the expected results, especially with certain languages and fonts. So we decided more work was needed to improve the accuracy of the transcriptions. This transcription enhancement was carried out by 4 people working part-time on checking and correcting the transcriptions. We also set up a pilot volunteer project, and the flyer we used for recruiting the volunteers is shown on the slide. As well as knowledge of languages and ideally experience of working with rare printed material, we found that the most essential quality in volunteers was perseverance, as the work is very repetitive and requires concentrated attention, which is why we didn't have anyone working full-time on this task. Next slide. The accuracy of the transcriptions before this manual enhancement depended on a number of factors. First, language. The average accuracy for Hebrew text before enhancement was only 47%, but was much higher for English and other European languages. The script used was also a factor. So in the pamphlet at the top of the slide, you can see that the software has not been able to read the line in Gothic script at all. Specific software is available to deal with Gothic text, and external services can also be used to provide corrections on a cost per page basis. But we decided this wasn't worth the cost, as Gothic script mostly appeared on title pages and could easily be corrected manually. There were only a small number of pamphlets where it was used in the text. Certain Hebrew scripts were also problematic. The example on the bottom right is a semi-cursive script, where very little of the text has been transcribed successfully. Vocalized Hebrew text could also be a problem. A bit like Bengali, as we were hearing earlier, the Hebrew alphabet only includes consonants, and vowels are indicated by symbols above or below the line. In the pamphlet on the bottom left, these vowel symbols have been read as a separate line of text and superimposed on top of the consonants. The date of the pamphlet could also be a factor, as older text might include non-standard characters. So, as in the top example where it says historical, the long S has been misread as an F. In cases where the software had difficulty to transcribing any of the text correctly, it would have been more time efficient to transcribe the text manually. In other words, overwriting the existing text completely and retyping it, rather than by using software to correct the text on a letter-by-letter basis. However, such overwritten additions, although searchable in the final PDF, would not have been linked to the corresponding text in the document image. And for this reason, this practice wasn't adopted.
So once the transcriptions had been corrected, they were checked to monitor quality. Unfortunately, the searchability of some of the PDFs was still found to be inadequate, and initial testing showed that many of the manual corrections were not discoverable in the PDF text. And in addition, sections of the text which had already appeared to be correct in the transcriptions were also failing to be discovered in the completed PDFs. So we were puzzled by this and tried highlighting areas of text and copying these into a Word document. We then set this to show all the hidden formatting symbols by selecting the paragraph icon, which reveals the hidden characters. This led to the discovery of instances of spacing within words, often separating each letter, and these can be seen in the example. So for example, the PDF is on the left, and on the right is the transcription. And spacing can be seen, for example, in the word printer and in the address of the printer, and under the word indigent blind, practically every letter has a space in the text supported by voluntary contributions. And there's also a space, as you've spotted, in indigent blind there. So obviously this was hindering searchability and discovery. So we experimented with using the style editor, simply because we'd noted that the worst cases of spacing were in the smaller fonts. So you can see in the original there were some very small fonts used, and that's where the spacing seemed to occur. So using the style editor, we could actually enlarge the size of the font in the transcription. And so this enabled us to identify the minimum font size required to eliminate instances of spacing in different languages. And as a result, we revised the methodology and were able to set the font sizes prior to correcting the transcriptions. We also took the precaution of monitoring the quality after correcting just one page before we changed the whole text. I think it's important to say here that Abby very kindly offered us a free trial of version 14 because we'd reported some of these problems to them. And we found that version 14 did resolve much of these issues. But as I mentioned earlier, we'd already done a lot of the preparation work in version 11. And so at this point of the project, we didn't really want to risk slippage by migrating to a different version. So monitoring the quality enabled us to calculate overall improvement. And this table shows the accuracy rating before and after transcription enhancement. The last column here shows the overall improvement, taking the original accuracy figure into account. So it's quite clear to see that Hebrew script here benefited the most. So from 47% to 85% accuracy is actually an 81% improvement in the quality and overall. But there was less improvement for Roman script. And then going to the date of publication, we found that it was more beneficial to carry out this transcription for pre-1800 publications. So I will finish with a few metrics that we gathered doing the projects were quite interesting. So to start with, you'll see that 81 transcriptions were completed, and we corrected 1,779 pages. And it took approximately a minimum of 1.5 hours to correct the Abbey files for each pamphlet. The final assessment, the average time per page was approximately 10.4 minutes. And it took about half an hour at the end of the transcription process to assess each page and to carry out any remedial corrections. But a lot of these figures are sort of averages. And so my last sort of metric is the average minimum time taken per pamphlet is 6 hours. And when I say average minimum, I would say is what we've been talking about in the conference, the minimum time you take to make something good enough. Because if we talked about the average maximum time, it would be infinity, really. There would probably be no end. So we were trying to make the pamphlet good enough. And we estimated it was about 6 hours per pamphlet. I think if we were doing this again, Vanessa, we would try and work out we do a page count and base it on the page count if we could.
Can you go to the next slide? So finally, here are some of the lessons we learned from the project. First, it's important to document procedures in detail so that all staff and volunteers are following the same procedures and to inform future projects. It's essential to monitor the quality of the transcriptions at each stage of the process. As we discovered, some transcriptions were less accurate than we expected. And it's essential to then revise the methodology as necessary. We realised our expectations weren't always realistic. For example, some of the volunteers were working on very long pamphlets, which could be quite demoralising because of the slow progress. In the future, we would target material where the manual transcription enhancement would make the most difference. As you just heard, for this collection, that would be pre-1850 publications and texts in Hebrew. And finally, there's a fuller report about the project, and we've included the URL on the slide, and I'll also share it in the chat. Thank you very much.
Thank you very much. Thanks very much, Andrew. Thanks very much, Vanessa. That was terrific. A lot to think about there as well. And we've had a lot of questions coming in. Why don't we take a 10-minute break? Everyone can relax for a few minutes. We'll come back and we'll have a question and answer session with our excellent panelists. So thank you all very much, and we'll see you back here in a few minutes.